Alright, today we are talking about finding exact area under a curve. So for this problem right here, we're going to find this area in here from x equals 1 to x equals 3. What we used to do is we would take these little boxes and make them nice and small as we could, and we could estimate it. Well, we don't want to do that anymore. We want an exact area. So what we're going to look at is how can we find this exact area without having to do any of this rectangle garbage. So, well, first what we can look at maybe is, can we do something geometrically? Well, we would set up first as an integral, because that's what area under a curve is an integral of f of x, which is x plus 2, dx. And we set up our limits because we want to go from where it's equals 1 to equals 3. Well, if we can do it geometrically, that means that this thing right here is some geometric shape that we know and know how to find the area for. Well, actually, we can do that here. This is a trapezoid. Trapezoid, the area is 1/2 times the sum of the bases times the height. It's 1/2 times, well, what are these bases here? The bases of the two parallel parts. Well, this base goes up to 3. The other base here goes up to 5. The height is the distance between the bases, which is 2. So that's 1/2 times 8 times 2, which gives me 8, we would say, units squared. That's the area. If you can do it geometrically, then do it. I mean, this, like I said, is just the area of a trapezoid. So, I mean, do what you got to do. If you can do it with those, you'll see sometimes in problems where they give one with half circles or triangles or squares, rectangles. You can find that's what an exact area is. Now, obviously, you can't always do that. So what we're going to be using is called the fundamental theorem of calculus. And if you have this crazy curve where there is no geometric shape I can really tell, I can find it, what the actual exact area is, using the antiderivative. So if this big F is the antiderivative of a little f, all I need to do is take the antiderivative and evaluate it both at B and at A and subtract. That's all we have to do, and I can get an exact area. So let's use that exact same one. What you have to do first is take the antiderivative of both sides. Take the antiderivative of it. So x will become something x squared. We need it to be 1/2 x squared. The 2 will become a 2x. And remember, when we take a definite integral here, we do not need to have a plus c at the end. Now our notation here, we're going to put this little bracket and put a 1 and a 3. That just means we want to evaluate this whole thing here at both 3 and 1 and do that subtraction like our formula just said. So let's start with at 3. So when it's at 3, what I'm going to have is 1/2 times 3 squared plus 2 times 3. Then I'm going to subtract that whole thing. So I want to take this whole part here. That's a big key. I want to look at the whole thing. And then I will subtract it by the other part, which will be 1/2 times 1 squared plus 2 times 1. Okay? So we're looking at this whole one, and we're looking at this whole thing with 3. And from there, it's just, can we simplify it? This will end up being, this part here will be 9 over 2 plus 6. This whole part here will become 1/2 plus 2. Again, keep these in parentheses so we don't mix them up. Do all that addition and subtraction, and you get an answer of, you guessed it, same thing, 8. And that should match again what we did when we did it here geometrically. 8 units squared. Same thing here. We add all these up. 9/2 minus 1/2 will give me 8. 4, and 6 minus 2 will give me another 4 to give me 8. So, the ways you can find exact area geometrically like we did first, using the fundamental theorem of calculus, or one of the easiest things to do, and which will always work, this one always will work. Geometrically, very rarely will it work. Fundamental theorem of calculus, probably 95% of the time that you have to do a problem, you can use that and it'll work just fine. Calculator always works, but remember, we're not always given the calculator. So how do you do a calculator problem real quick? Say I would do the same thing, plug it into my calculator, I would plug into y the function x plus 2 and graph it. Then you want to hit the calculate button, which is normally the second function under trace. and I think it's the seventh one down usually gives you this integral function. It'll ask you for a lower limit, and an upper limit. Well, if we're doing that same problem, the lower limit is just the bottom number of that integral, which was the 1. The upper limit is the top number, the 3. And then you hit enter, and it would give you that same picture. If you had that graph like this, it would give you this, and it just does the shading, and it does all the work for you. So like if you got a problem like this, I would have no idea how to solve that problem. There's no way with anything that we're going to learn that'll tell you exactly what steps you need to take to solve this. However, if I just went and typed that into my calculator, just that exact way, do the second trace function, and I can calculate what the integral is going from 0 to 5, and it will tell me immediately that it just comes out as 300.74. It just does it right for you. So those are different ways to use it. We'll do some more work with the fundamental theorem of calculus as we go along, but that is the biggest part that we will have for the rest of the year in terms of doing our calc problems.